Hi everyone, welcome back to another Algebra 1 tutorial. In this video we'll be going over solving systems of linear equations. So the key concepts for this video is going to be solving systems by graphing, substitution, and elimination. So systems of linear equations. So a system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two or more variables is an ordered pair that satisfies each equation in a system. So to simplify, suppose we have a set of linear equations. So we have x plus 2y is equal to 6, and we also have x minus y is equal to 3. So we're basically finding a set of values for the x and for the y that work for both of these. So basically, what is x plus 2y is equal to 6 and x minus y is equal to 3, but x has to be same for these two and so does y. So for this one, if we substitute 4 for x and 1 for y, so we get 4 plus 1 into 2, which is 2, is equal to 6, which works. Similarly, we have 4 minus 1, which is also equal to 3, which is equal to 3. So that also works. Thus, since we have a set of x and y values which work, we will write it in an ordered pair form like so. So the solution to the system of linear equations is 4, 1 in ordered pair form. Solving systems. So to solve such systems and get an ordered pair, we first need to know what we are solving for. When we are solving for the solution, we're solving for the intersection of two lines, which were graphed, or the points of intersection. So to visualize, let's graph two functions. So let's graph y is equal to negative x minus 1, as well as y is equal to x minus 3. So let's first get the coordinate plane. So now that we have x and y axis, let's first do the simplest way to draw a line, which is find two random points. And since we have the slope and the y-intercept, and since it's written in the form y is equal to mx plus b, we can directly go into finding the x and y-intercept. So if we want to find the x-intercept for this one, we can substitute y with 0 to get 0 is equal to negative x minus 1, and we're going to get negative x is equal to 1, and x is equal to negative 1. So the x-intercept is negative 1, 0. So similarly, if we want to find the y-intercept, substitute this with 0 to also get the y-intercept as negative 1. So now we could graph a line. So connecting these 2 points, hopefully. Let's get 2 points over here. Okay. So now that we have 2 points, let's graph our first line. So that would be our first line. And now let's graph one more line, which is y is equal to x minus 3. So finding the y-intercept and x-intercept. So we get the x-intercept as, so y is equal to x minus 3, substitute this with 0. So we get the x-intercept as 3. So 1, 2, 3. And the y-intercept as negative 3. So 1, 2, 3. So now let's draw another line. So we have 1 point over here and 1 point over here. And now we can graph our second line. So now that we have 2 lines, we can see that they seem to intersect somewhere over here, which seems to be 1, -2 are going to be the coordinates. So 1, -2 seem to be the coordinates. So what we're solving for in a solution of a system of linear equations is the intersection of the two lines when they're graphed, or an ordered pair which works for both equations. So suppose even if we check here, we'd get -2 is equal to -1 minus 1, which is -2, and y is equal to x minus 3, so -2 is equal to 1 minus 3, which again gives us -2 is equal to -2. So solving equations by graphing. So basically what I just did before was solve them by graphing. So what we can do whenever we graph is we can get the function, we can extract the intercepts, because mostly it's going to be written in the form y is equal to mx plus b, or it can be manipulated in a way that we can change it from any other form to y is equal to mx plus b. And after that we can substitute the y with 0 to get the x-intercept and vice versa. And after we draw both the lines, we can finally look at the point of intersection. And usually for these problems we can check as well, so we can use the ordered pairs to substitute them in for x and y correspondingly to get the values. So for example, suppose we're given y is equal to -2x minus 1 and y is equal to x plus 5. So first step would be to graph them out. So we could do the following graph. Then we can get the y-intercept and x-intercept. So for this one it would be, so the y-intercept would be so if we substitute x with 0, get -1, so 0, -1. Similarly, so x-intercept would be, so if we substitute y with 0, we get -2x is equal to 1, so we get -1 by 2, 0. And similarly for this one, since this one is more straightforward, we can get y-intercept as, so we could get y-intercept as, substitute x with 0 to get 5, so 0, 5, and x-intercept is -5. So we could plot them down like so. Zero, -1 as the y-intercept. -1 by 2, 0, which would be somewhere in between over here, so we could just estimate like there. And you could show one point over here. Estimate that the second point would be somewhere over there to get this line. And next we could get the second line, so 0, 5. So x-intercept 5, so 1, 2, 3, 4, 5. And -5, 0, so 1, 2, 3, 4, 5. So we could get a second line in using the same method, and there. So now we see that this is the point of intersection. So we can see that it intersects somewhere in -2 and close to 3. So we can say that this point is -2, 3, like as an estimate, and we can even check. So -2 over here would give us, so y is equal to -2x minus 1. -2 into -2 gives us 4. So if y is equal to 3, and then so it would be 4 minus 1, which is also 3. And similarly here we can get 3 is equal to -2 plus 5, which is also 3. So now that we see that these work, we can say that the solution to this system of linear equations is negative 2, 3. So another way to solve for a linear equation, so for the solution of a linear equation, is by substitution. So the step-by-step process would be solve for one variable in at least one equation, substitute the resulting expression into the other equation, solve that equation to get the value of the first variable, and substitute that value into one of the original equations and solve. And finally, write the values from step 3 and 4 as an ordered pair, which is x, y, and check. So remember, the check step is very vital because it lets you be confident about your answer. So let's solve this problem. We have y is equal to 2x and y is equal to x plus 5. So right off the bat we can see that this y is assigned to 2x as well as this y is assigned to x plus 5. And since y is equal to y, we can say that x plus 5 is equal to 2x. So x plus 5 is equal to 2x. So now that we have that, we can do a subtraction to get x is 5. Now that we have that, we can substitute 5 over here to get y is equal to 2 times 5, which is y is equal to 10. And similarly for the other side, so 5 plus 5 is equal to 10. So y is equal to 10 for both sides. So now that we have that, we can write them as an ordered pair. So 5, 10. And this would be our solution. So now we can check. So y is equal to 10 is equal to 2 into 5, which is also 10. And 10 is equal to 5 plus 5, which is also true since 5 plus 5 is 10. So now that we have that these two values are true, we can conclude that 5, 10 is the correct value, or correct ordered pair. So now let's solve a few more problems. So we have y is equal to 2x plus 10 and y is equal to negative 2x minus 6. So right off the bat, we can see that the values are given to us straightforwardly. So we can say negative 2x minus 6 is equal to 2x plus 10. Then we can bring over 2x to this side to get negative 4x minus 6 is equal to 10. Then we can bring over 6 to that side to get negative 4x is equal to 16. And then we can divide both sides by negative 4 to get x is equal to negative 4. So now that we have that, let's substitute it for this one. So y is equal to 2 times negative 4 plus 10, which gives us y is equal to negative 8 plus 10, which is 2. So now that we have two values, we can say that the ordered pair is negative 4, 2. And if we substitute in the values, we get 2 is equal to negative 4 to negative 2, which is 8 minus 6, which gives us 2. And similarly, we can say 2 is equal to negative 4 into 2, which is negative 8, plus 10, which also is 2. So now that we have both values, we can conclude that negative 4, 2 is the correct solution or ordered pair. So let's solve one last problem. So in this problem, it's not given to us right away. We are given two functions in standard form. So 3x minus 2y is equal to negative 7. So for this one, we can see that the easiest way to do it is isolate first the y values on both sides. So y is equal to 4 plus x, and negative 2y is equal to negative 7 minus 3x. Then we can substitute both sides by 2 to get y is equal to 4x and y is equal to 3.5 or 7 by 2 plus 3 over 2x. So now if we substitute it in, so this one's more complex, 3.5 plus 3 by 2x plus 4, or not plus 4, is equal to 4 plus x. Now all we need to do is add some to some sides and multiplies to some sides. So 4 minus 3.5 gives us 0.5, and 3 by 2x, which is basically 1 by 2x or 1.5x minus x is equal to 0.5x is equal to 0.5. So which means that x is equal to 1. And now if we substitute it in, negative 1 plus 4 is equal to negative 1 plus y is equal to 4, and y is equal to 5. So our solution would be 1, 5, and we could substitute it in. So 3 minus 10 is negative 7, because 3 into 1 is 3, and negative 2 into 5 is negative 10. So 3 minus 10 is negative 7. So similarly for the other one, negative 1 plus negative 5 or negative 1 plus 5 is equal to 4. So we can conclude that this is the correct solution. So finally, let's look at one last way to solve for the solution. So the final way is to solve by elimination. So what we can do is we can get one variable with the opposite symbol in such a way that they cancel each other out, and finally leave one variable aside to the one constant. And we need to make sure that both equations stay true at all times. So to visualize, let's solve this one. X minus 2y is equal to negative 19, and 5x plus 2y is equal to 1. So here we can see that negative 2y and 2y cancel each other out and make 0. But if we add these two, we get 6x. So we can add all the sides together to get 6x is equal to negative 19 plus 1, which is negative 18. We can divide both sides by 3. We get x is equal to negative 3. So now that we have that, we can do negative 3 minus 2y is equal to negative 19. We can get negative 2y is equal to negative 19 plus 3. Negative 2y is equal to negative 16. And finally, y is equal to 8 if we divide negative 2 on both sides. So we have x is equal to negative 3, y is equal to 8. And we can put this in an ordered pair to get negative 3, 8. And if we substitute it in for both, so x minus 2y is equal to negative 19 and 5x plus 2y is equal to 1. We see that if we substitute on both sides, we get that the ordered pair is true. Thus we can conclude that this is the correct solution. Okay, so now let's solve another problem. We have 2x plus 4y is equal to negative 4, and 3x plus 5y is equal to negative 3. So for this problem, we see that it doesn't directly give us two cancelable values. So instead, we need to multiply it in such a way that the equation stays true, but we can still get one of the values and then lead on to get another. So here we can see that if we multiply this side by negative 3 and this side by 2, we can get the value. So negative 3 into 2, negative 6x minus 12y is equal to 12. And 6x plus 10y is equal to negative 6. And if we subtract, so 0, negative 2y is equal to 6, and we get y is equal to negative 3. So now if we substitute it in for one of them, let's substitute it in for this one. We get negative 2x plus 2x minus 12 is equal to negative 4. And we get 2x is equal to negative 4 plus 12, which is negative 8, and x is equal to negative 4. So we have a set of values, negative 4, negative 3. And if we substitute it in, we get negative 8 minus 12 is equal to negative 4. And similarly, negative 12 plus 15 is equal to negative 3. Or negative 15 plus 12 is equal to negative 3, which gives us negative 3, which works. So we can conclude that this is the correct ordered pair. Thanks for watching. Make sure to like and subscribe if this video helped you with solving systems. Also, thank you guys so much for 10 subscribers.